Q&A. Excellent. It is being recorded. Feel free to pop things into chat as we go along, and we'll definitely have time to address any questions, comments, or concerns. As Elizabeth said, I'm one of the co-founders of Protocols.io. I'm a scientist by training and did my PhD in Berkeley, and it was my postdoc at MIT where I spent a year and a half correcting just one step of the protocol, single cell microscopy protocol I was using. Sorry? Oh, so what I was saying was that I spent a year and a half correcting just one step of the microscopy protocol. Instead of a microliter of a chemical, it needed 5, and instead of 5 minutes in the tube, it needed 15. And then you realize that's not a new technique. That's a correction of something previously published. So it's not a new paper. I don't get credit for it. And more importantly, everyone who's using that method is getting completely misleading single cell quantitative results and has to spend a year or two rediscovering that tweak. So I became sort of obsessed with creating a central place to exchange protocol-focused knowledge. And as we said, I'll show just a handful of slides for a background on Protocols.io, and then mostly just live demo of what the platform is, and then we'll have plenty of time for Q&A. And my personal sad story aside, I have been bookmarking over the years. We launched in 2014. I've been bookmarking over the years on social media, people complaining about the difficulty of finding the details of methods that they need and published research papers. I come from genetics, molecular biology, but I think it's pretty broad. So here's a biologist, postdoc from UC Riverside saying, I'm looking for a protocol in a 97 paper in the method section as described in 96, finds 96 paper as described in 87, finds 87 paper, paywall, even if you're part of UC. This is a physicist who is reading papers, and the method sections say devices were fabricated as previously described, and the original reference just says devices were fabricated with conventional methods. So this is a pretty common and frustrating experience. It's not limited to life sciences. It's pretty general problem in the world of research. There is less anecdotal, but from the world of life science, there was a more quantitative assessment, not explicitly of the protocol sharing challenges, but there was a reproducibility project from the Center for Open Science and Science Exchange that picked 50 cancer papers with something like 190 experiments in them that they wanted to independently replicate to see if they get the same results outside of the team that did the original work. This was started in 2015 and 2017. There was a lot of attention to the first results from this project. It was in Box and Atlantic, so a lot of media coverage, and Ed Young in the Atlantic writing about it. And he said that the hardest part by far was figuring out exactly what the original labs actually did. As we all know, as researchers, the science papers theoretically have recipes for doing the experiments, but a lot of the times they're missing. And a year and a half later, the entire initiative just stopped at 18 out of the 50 papers they set out to assess as part of this initiative. And big part of that was the difficulty of getting the actual protocols. And what's interesting, why I highlight this, is that it's not just about the published papers and the external reproducibility when we read what is in the method sections, but in this initiative, Center for Open science, the team members actually approached and collaborated with the authors, with the labs that published these 50 cancer papers. And a lot of the times the teams themselves couldn't find it because the postdoc has moved on, the graduate student has graduated, no longer there. And even if you can contact the person, the exact protocol is somewhere in their lab notebook in 1,000 pages from 5 years. And it wasn't always clear, even when you contacted the original team that did the work, it wasn't clear to that team which version of the protocol, what exactly did we do to generate this result. And if you go to the Center for Open Science summary page on this initiative, you'll see that they said that out of 193 experiments, 0% of the papers had the protocol adequately described for someone to follow up on it. And this, what I call external reproducibility, what's in the papers, and internal reproducibility, what's in our teams, research teams, as people graduate and as new people join, how well organized are the methods. That's exactly what we exist to improve. And as I said, we launched in 2014. So this is a snapshot of where we are today. There are two sides, just being transparent. There are two sides to Protocols.io. There is a public repository, and you'll see there's about just shy of 20,000 public open access protocols. And then what we charge for is the private collaboration. That's where university site licenses, company subscriptions, if you're in industry, that's where those come in. So there's about 90,000 private protocols. And most of these are indexed in Google and Google Scholar. They're not PubMed. We're not a journal. We're a platform. But I think about 60% of our traffic, the 1 million people that visit every year or so, most of that comes from Google. And the public side, that's a Wikipedia-like crowdsourced repository. So if you're sharing your knowledge publicly as part of publication, just to get credit for your method development work, to improve the reproducibility of what you're publishing, that side is completely free. It's free to read, free to publish. These are open access CC BY protocols. And it's the, as I said, private side that we charge for. And the overall mission is just to make it easy before, during, and after publication to share method details. So with that, I will come out of the slides and show a live demo if internet cooperates. But any questions so far before we transition to the platform itself? No? And as I said, there will be plenty of time for questions. I'll show one of the biology examples as a public protocol in terms of the functionality. I do want to be transparent. So my background, as I said, is in genetics. There is a bias on Protocols.io towards life sciences and molecular biology. But I think it was around 2017 that our landing page, instead of saying repository for life science methods, we broadened it to repository of research methods, as more and more non-biology or general journals started adding Protocols.io to author guidelines. The scope expanded. So today there are examples from physics, from psychology, anthropology. There's still a bias towards molecular biology, but you'll see that since 2017, there's been expansion in the types of researchers that are using Protocols.io. And one of the most important things for me to get across is that as long as it's a research method with step-by-step instructions, we really warmly welcome contributions from all disciplines. So with that said, I'll show the functionality is the same regardless, of course, of what the discipline is, more or less. And I'll show one of the public examples, but every protocol starts out privately, just like Google Docs. You decide who to share it with, when to share it, what kind of access. Is it view only? Is it a co-author with full administrative rights on the protocol? Or someone who is a collaborator and can view and edit, but you own it and only you can publish it. And in terms of sharing publicly, it's a very explicit decision, and you go through a workflow. It takes a couple of minutes, but you do need to very consciously make something public. You won't accidentally expose things before you're ready. So you have a lot of control over how you're sharing. But whether it's a public or private protocol, the functionality on it is the same in terms of it not being just a fixed static PDF, but these are dynamic and interactive protocols. So we're seeing more and more protocols where people add video directly into a step to show someone how to do a procedure. And there are tables, images, formulas and tables. But one of the really nice things, I think, in addition to all of the structure and editor features that apply to the protocols, one of the really nice things you'll notice is that if you mouse over any step, you can ask a question right on that step that will go to the authors and to everyone who is using the protocol. So you can see on step 2 over here, there is a thread with questions and answers right on step 2. So instead of it happening on social media, it's here today, gone tomorrow, or by email or in Slack, the conversations are happening right on the protocol. You can ask privately. Obviously, if it's a private protocol, you can't ask publicly. But if it's a public protocol and you ask a new question, you decide whether to ask it publicly or to send it as a private comment to the team behind the protocol. But as conversations happen, you're sort of building a public FAQ right on the protocol. And even though every protocol, if it's published, it gets a DOI, it's citable, it's preserved and mirrored, we do make it with a click of a button very easy to update. So you can see I can navigate between version 1 and version 2. You might have a small typo, or you might have a major change to the protocol a year later, and you can come in and share a new version. There is, on every protocol, there is a compare button that allows you to see which steps are the same, which ones have changes to them. So 3 through 8 are the same, then something is updated in step 9. And this allows you to have a version that makes it easy to share corrections and optimizations at any point, but the previous versions don't disappear, and we just naturally guide everyone towards the most recent copy. So if you land from a published paper, if you land on a link on version 1, you'll just get a notice saying that you can view this, or you can go navigate to the newer version of the protocol. And then the other thing that I wanted to highlight is that every protocol serves as a sort of template. So if you're familiar with GitHub, there is forking, same thing on protocols.io. Any public or private protocol, you can make a copy of, and this may be something as simple as you're studying crickets, I'm studying grasshoppers, and there's slight tweaks to the protocol. So it's not that one is correct or one is more updated. It's that there are different flavors of it depending on the tools we're using, the area where we're doing the research, right? Or the organism that you're studying. So whatever the reason is, every protocol is essentially a template that you can copy and as soon as you click that, you get an edit button, and you can use any of the protocols in the public repository or the ones that are in your private space that are shared with you. You can use them as templates. You can then edit them and have a branch of it that is specific to your conditions, to your experiments. And that compare functionality that I showed between versions also applies to the forks. So you can see in a snapshot with a click what stayed the same and what's different. And you can also, if you're publishing, you can also make a fork public. And we try to give credit. We make it very clear what the original is, that the title, we would steer you, make it clear what's the original, what's the fork, that compare functionality is there. And we try to give credit to the people that shared the original and to the people that are sharing the changes and edits and optimizations possibly in a fork. And the last thing that I wanted to highlight on the protocol level is that there is, so I think about 5 to 10% of the public protocols, maybe closer to 5 of the public protocols that we have are computational dry lab workflows, but the vast majority are hands-on field or wet lab techniques. And for those, the run button is kind of like a cooking checklist app that allows you to step through the protocol and see where you are, what you're doing next. If you have a timer, you can start it on your iPad, right as you're, or a Samsung tablet as you're performing the work. You can see where you are in the experiment, what's next. And importantly, if you change anything, there is an edit button. If you change anything at runtime as you're doing the work, you can click edit and say, today I didn't do it at room temperature, I did it at 20 degrees. And you're not changing the underlying protocol, but you have a lab notebook-like record of how exactly you ran it on that particular day. And it gets saved in your space on protocols.io. It's also easy to export it. There are some lab notebooks, electronic lab notebooks that have connected to protocols.io. So it's very easy to get it out of protocols.io and print it, put it into your physical notebook, or just have it on protocols.io or send it to the ELN. And the last thing I wanted to show in terms of the functionality before coming back, one of the last two things I wanted to show is that if you sign in, I was showing the protocol level public side, but if you have an account, if you sign in, it's kind of like a file manager. Most of the time you'll spend in what we call workspaces, and that's the space where an entire research team, consortium, we have workspaces with 500 people, 10 people, so it's up to you what kind of workspace. But that's where you can have folders, subfolders, organize all of the protocols, related files that are relevant for them. And I didn't mention that I'm not going to go, unless there is interest in seeing the editor, I'm not going to showcase every button and every feature in protocols.io, but we did put in a lot of work into the editor. So it's kind of like Microsoft Word, but specifically for protocols. And we also make it easy to attach Excel files, images, scripts right on step level where you need to, but you can also add PDFs, zips, whatever you need into the file manager space so that everything that you need for a particular protocol is organized in a sensible fashion. There are a lot of administrative tools for these workspaces so that as people join the team, it's easy to add or remove people. And if you're collaborating in a workspace, everyone has access to the same protocols, everyone is on the same page. But if you have collaborators outside of your team, you can also easily share individual protocols without fully inviting someone into the workspace with all of the privileges. All right. So this is, again, just for transparency, on the free plans of Protocols.io, you can create 2 private protocols. And then if you try to create a third one, we ask you to make some of the existing ones public or to subscribe. Most scientists and researchers who have access to Protocols.io Premium, they have it through their institutional plans. And I think we are talking to the University of Kentucky about possible subscriptions sometime next year. So if you think it's relevant and would be useful, you can advocate and help convince the university that it would be a good tool, but we don't really expect individual teams to bring us to sustainability and be the backbone for the business model. So really, mostly it's about the site licenses. Because it can take months, sometimes years, for a university to subscribe. If your team is using Protocols.io, if you're advocating for it, but the university takes a while and you do need it in premium, you can contact us and where would it be? And we do have waivers. So if you don't have funds and you don't want to pay for an individual space and it's taking a while for the university level discussion, there is, we call it the academic research program. There is a short form to fill out, and if you'd like to use it in premium mode while we're talking to the university, we are happy to give waivers for individual teams. All right. And I will, as I said, I wanted to make sure that we have plenty of time for Q&A, so I will wrap up. This is just an example. We do, as part of this mission, we really do try our best to make it easy for you to get credit and recognition for developing methods and the hard work that might be 1 or 2 sentences in the method section of a paper, research paper that you publish, but there can be half a year of work behind getting a technique to work. So it's easy to share and make your protocols discoverable. Here is a professor from Australia saying 80% of my collaborations have been a direct result of sharing my methods publicly on Protocols.io. But I also do want to say that we have a growing number of journals that will peer review protocols from Protocols.io and help you turn those into actual published peer-reviewed papers that would be in PubMed and that would count as formal publications. Again, because we're a platform, we're not a journal, but we do have a growing number of partnerships with Springer Nature journals, with Public Library of Science. That was PLOS ONE was the first journal that partnered with us, I think 3 years ago towards this, but there's a growing number of journals that welcome protocols for peer review from Protocols.io. And as Elizabeth mentioned, there's more and more funders that expect or require sharing of protocols and recommend Protocols.io, more and more recognition of the importance of method sharing. And I wanted to finish with the slide to say that in addition to the 5 or so journals that explicitly welcome protocols for peer review, there are maybe 1,000 journals now. It says 500 plus, but there are a lot of both open access, subscription. There are a lot of journals that explicitly have Protocols.io in their author guidelines. And for transparency, we were a startup, independent, and launched in 2014. But a year ago, in July of last year, in 2023, Springer Nature acquired us, which means that we now have more resources, have more stability. We're not a precarious roller coaster startup, always a month from bankruptcy and an existential crisis. So we're stable. we are part of Springer Nature, but I did want to emphasize that we remain an independent platform. It's not just for Springer journals or Nature journals. And this year, Wiley added Protocols.io to all of the author guidelines. And as I said, there's a growing number of funders. There are a lot of NSF program officers and AH program officers, like Elizabeth mentioned, that encourage sharing on Protocols.io, and more universities that have been signing up. This is a little bit about preservation and long-term, ensuring that the protocols are available in the long term. We make it very easy to export protocols and your run records. You own the content. These are your files. So we make it with a click of a button easy to export everything from your workspace, to send it to Open Science Framework using their authentication. We've integrated with Center for Open Science, OSF, and other cloud services like Google Drive. So we do try to make it easy to get your stuff out of Protocols.io and not to have lock-in. We have public APIs, and we also mirror all of the public protocols in several places to make sure that there is redundancy, and if there is any problem with our Amazon server, that you can still find access to the protocols that you need elsewhere. And with that, I will stop sharing. I think we're exactly at 30 minutes, and I am happy to take any questions. And you can either put them into the chat or just feel free to. There's not that many of us. You can unmute yourself and ask away.
So Lenny, I had a question. You were going over one of the protocols, and I noticed there was a reserve DOI.
Mm-hmm.
So is that for, say you're sending your protocol for peer review through a public, like you would do a DOI for a data set, you would send that DOI, but it wouldn't necessarily, but the data set would not be accessible to the public, right? Is that how that would work, or is that different?
That's exactly
Okay.
right. We've never had an instance, like if you share protocols publicly, we've never had an instance for those 20,000 protocols that we have since 2014. We've never had an instance of someone submitting their paper for publication and the journal saying, oh no, you've shared the protocol previously. However, if you're not ready to share the protocol and you want to make sure that your paper is accepted, that's exactly what that reserve DOI is for. So you click reserve DOI, you can put it into the manuscript. There's a private link for the editor and reviewers to access it. And then once the paper is accepted, you fully publish it, maybe on the day it comes out, or right before, you fully publish it so that the DOI actually goes to Crossref and starts resolving. So the reserve DOI allows you to give access to editors and reviewers without having it go fully public. So as I said, it's completely your decision how and when to share.
Perfect. Thank you.
Absolutely.
Hi. I may have missed this in your talk, but is there room for like some discussion about the approaches that you're taking in a protocol? Because like the examples that you showed are very like linear, I guess, in train of thought. But some of the stuff that we're doing, there might be other considerations, like if you have this situation, then do this. But if you have a different situation, then do Y as like one of the steps, like so we could be a little bit more verbose or include some figures in that. Is that possible?
Absolutely. And thank you. So I'll click share again. And that is a great question. So if we go into the test, so one of the things I wanted to mention is you can create a protocol, but you can also create a collection. And you could have 3 related protocols. So it creates a sort of container. Sometimes we see people creating collections if they want to share 10 different protocols as part of a publication. So instead of citing each one, you get a DOI for the collection. You say the methods are available here. Sometimes people create collections exactly for this reason that you're describing, because they have 4 different versions, and depending on whether you're doing the experiment in Arizona or in Utah, you might have slightly different steps. So you could collate them together. So those are options with the collection, but actually when you're in the editor, there is a step case, which is kind of what you're asking, and that's a branching logic. So you say, if in Utah, so there's a case title, if in Utah do this, and if in Arizona do that, and then your protocol. So you might have the first 15 steps of the protocol may be the same, and then the rest of it can branch out.
Right.
And the other option is, we have on the right-hand side our components, and some of it is generic, computational, chemistry, but one of the components you'll notice is a protocol. So if you have protocols on protocols.io, you can actually insert them as subprotocols into a technique. So you could say, if you're doing X, use this subprotocol. If you're doing Y, use that one. So the step case and the subprotocols, I think, give you that flexibility, not just to have a linear flow.
Awesome. Thank you.
Absolutely.
I'm
And
gonna pick on. Do you mind if I pick on Meredith? Meredith, do you have any example that you want to show potentially?
Not specifically to show, but
Okay.
just for like a little bit more context. So we're setting up something that we would hope to publish in terms of setting up flood modeling for either Kentucky or different areas of Appalachia or different regions entirely. So that would look something like, if you're trying to model this scenario, steps A through D, and you're going to get data from this repository from, publicly available data sets if you're in this state versus this one for this state, that kind of thing. I think that's what Jason was getting at when he talked about it being a nonlinear, convoluted kind of situation.
yeah, we've seen, with the breadth of the protocols that we have, I think we've seen all of those, and we've been, I've been out of the hands-on research for over 10 years now because of protocols.io, but we have something like 160,000 registered users, and we're really good at listening to input and requests. So we have a pretty big engineering team, designer, and we've been trying to constantly get examples like yours and see if there's anything we need to improve in what we're supporting, in the components that we have in the editor, to really make sure that it's not just for cancer biologists and yeast geneticists. So I think we're pretty good at it. I think you should have, with the collection subprotocols and the step case, you should have all the tools, but I do want to emphasize, I put my email in. Also, we have other scientists on the team in US and in Europe. And as you play around, if you have questions, if you want to jump on a call to ask, how do I do X? We're really good at answering emails. You can also request, I'm putting it into the chat right now. If we don't get to your question today, if it's hard to explain by email, I just added a link in the chat. You can reserve a one-on-one demo at a time that's convenient for you on a given week, and jump on a quick call, share the screen. And if there is, so we do try to answer the questions. I think we have the tools for complicated workflows. That said, if you feel that something is not intuitive, or if you feel that you are working around and creating, roundabout solutions for something, that is super important feedback. That is helpful for us in improving the platform, which we continue to do. So connect with us, ask us questions, and if something can be improved. You don't have to come up with the improvement and tell us what to do, but if you tell us what's frustrating, I think we do a really good job of prioritizing that user feedback and improving the platform.
Awesome. Thank you.
And as I said, I put my email and the general info and the one-on-one demos into the chat. Any other questions? When we were a startup before the Springer Nature acquisition, there were a lot of questions what happens if you go bankrupt. So I always made sure to talk about that, but I think it's less of a concern at this point. So I don't have to preemptively address that.
Do you know how many protocols are related to geoscience on protocols.io?
So I think I pulled up some examples, but of the 20,000 protocols, I think about half are from life sciences and molecular biology. So we definitely do see examples from geosciences, but I wouldn't know necessarily other than going into the search on the public side and putting in geosciences or survey or river. I don't know the exact terms as a geneticist myself, but if you come to the land, if you just go to protocols.io, you can get a quick feel for it in terms of what's represented, what is there, just by doing searches on the public side. I know 100% that we have examples, that it's not just biomedical protocols that are here, but I can't give you a quantitative answer. Sorry about that.
No, that's no problem.
I will also put into, we actually have examples from different disciplines. So I'm putting into the chat. So you can see, people talk about setting up instruments and how to do sampling, but from many different examples and many different disciplines, you'll see what is represented on protocols.io, but just go to the search page and put in some of the terms, and I think you'll have a feel for what the gaps are. And we've to be honest, I thought this would be a side project. I was continuing my postdoc for a year with my co-founders. We all had jobs. One of the co-founders who's the director of technology right now and oversees all of the improvements. He was CTO of a Texas fashion blogging startup at the point when we launched this, but we're all trying to do this on the side. And we thought that it is something that would build over the weekends. And then I would just tell my researcher friends that it exists and goes viral, and we continue with our positions and just do this on the side. And after a year, we realized that it is a startup. We need to raise investments and get grants for this, and it's a full-time thing. But in the beginning, I thought it would just spread like wildfire, but it took us, if you look at the growth, to get to the 20,000 protocols that we have now, the first years, I think no one knew that we exist. We had 200 total protocols by the end of 2016. So it takes a while, and certainly some fields are overrepresented historically for various reasons, depending on the funders, on the journals that first added us to the author guidelines. But as I said, if you see gaps from the things you're working with, we would love to have more representation there, and we'd love for you to share publicly the knowledge that you have.
Great. Yeah, I was looking around. We're using it for developing a protocol. Monty's mainly writing it for our MSCL, and so tying that to the data that is created while running the MSCL. And so the protocol is the calibration methods. So they have information about data quality, how often was it calibrated, how was it calibrated, to kind of lean into the quality of the data that they're viewing. So that's one of the ways that we're using it now.
So that just reminds me, in the editor, like some of the components are self-explanatory, time, temperature, right? Data set that you were processing, link to GitHub. So those are straightforward. There's one component relating to what you mentioned that may be useful, that's not as straightforward. That one is called the smart component, and it's sort of key value pair. You can create a table saying, please record information, right, on temperature, humidity, whatever the fields are that you're trying to capture. And if you make it required, then when you're running it, in order to move on to the next step, you actually have to fill in, kind of like a form. You have to fill in the values. So that's the smart component. That should be helpful for that.
There any other questions or comments? Okay. Well, thank you, Lenny, very much. Really appreciate the walkthrough and just kind of explaining where this is kind of lands in the life cycle of data management and publication, where all this is kind of going. And you gave us your contact information. I have this recorded, so I'll everybody else send the recording out probably through Rebecca, and then as you guys kind of start diving in or thinking of ideas, if you have questions, definitely reach out to Lenny.
Thank you so much, everyone, for your time and for the questions. And don't hesitate to reach out if you have, as you're playing around with it, if you have questions or feedback. Thank you, everyone.
Bye. Thank
Thank
you.
you.
Thank you.
Have a good rest of the day.
You too.